Hi everyone, miss you so much. I'm sure the feeling's mutual. You don't have to tell me. I get it. Here we are, virtual learning. Your first couple things you needed to do weren't lessons. It was old stuff. I've been trying to keep the gradebook up to date, etc., etc. But we are moving into our circles unit now, so we have some new material for you. So the notes, it's up to you. The best way that works for you, you can either print this and write on it. You can fill out the Google Doc. Might be tricky with the visuals. Or you can do it in your notebook, whatever works for you. So here we go. 9.1, parts of a circle and tangents. So there's a lot of definitions, as you saw. So we'll just read through them. This is already populated, so I don't have to waste time writing stuff out. So the formal definition of a circle is the set of points equidistant from a given point, the center. So these are all the same distance away. And you can fill this out at your own pace, so I'm just going to read through them. A radius, this is a fun game. What if I do this? A radius is a segment with endpoints at the center and on the circle. The visual there. A chord is a segment with endpoints on the circle. So it doesn't matter where the line goes through as long as it's in the circle and the two endpoints are on the circle. A diameter is I'm so good at this. A diameter is this specific type of chord. It's a chord that passes through the center. And as you already know, the diameter is twice the radius. A secant is a line that intersects the circle in exactly two places. So when you look at a chord and a secant, the difference is a chord is a segment and a secant is a line. Then we have a tangent, a line that intersects the circle at exactly one place. So if you know the phrase like going off on a tangent, it's because the conversation is here and you're like, I can say something about that, and then you take it all the way off of the circle of the conversation. So that's a tangent line. And then the point of tangency then would be where the tangent line intersects the circle. So in this instance, the point of tangency is point Q. All right, next page. A central angle. We'll go back and do more lessons on these specifically, but for now, it's important that you're able to identify them. A central angle is an angle with a vertex at the center and two sides that are radii. So it's just like a piece of pizza. An inscribed angle is an angle with a vertex on the circle and two sides that are chords. So that's like, oh, well, that didn't happen. That's nice. So this would be an appropriate cake slice. This would be an inappropriate cake slice. Inappropriate, inscribed. Just thought of that. It might not make sense. Then we have arcs. Three different types. Ooh, see, it did happen that time. Of arcs. So generically, an arc is just a portion of the edge of the circle defined by two endpoints. And that's the symbol that we use for an arc. And then specifically, we have minor and major arcs. So a minor arc is an arc with a measure less than 180 degrees. So that's less than half the circle. And we use two letters to name that. And then a major arc is an arc with a measure greater than 180 degrees. So greater than half the circle. And we use three letters to name them. So arc AB goes directly from A to B. Arc ACB has to go from A to C and then to B. So even though they have the same endpoints, that C in the middle tells me that this is a major arc and is going in the opposite direction. And then finally, semicircle is an arc. So when we talk about the semicircle, we're talking about the arc. that has endpoints on the diameter. And a semicircle is 180 degrees. And again, we would use 3 letters for that. All right, so that's our vocab. So that brings us to this next page, name that circle part. So what you need to do is use the diagram below along with the word bank to classify each part. And parts can be used more than once. So give yourself a couple minutes. You can pause this and then get back to it and check your answers. Okay, because you have integrity, and definitely pause this and try this on your own. I will remove the hidden key so that you can check your answers. So again, you can pause and double check compared to here. If you have any questions or you feel confused or like maybe I got something wrong, feel free to comment on the assignment post and you can have a discussion with me or classmates to talk about it because we'll try to keep this as collaborative as we can in these weird times. Okay, so these are just the vocabulary words we'll use moving forward in this chapter. All right, more specifically, we're going to talk about tangents because that involves kind of the Pythagorean theorem, what we're working on already this year. So a tangent line intersects a circle at exactly one point, and we call that the point of tangency. And we know a special property for tangents is that a line is tangent to a circle if and only if it is perpendicular to a radius drawn to the point of tangency. So as you see here, A would be the point of tangency because our radius PA is perpendicular to the tangent line AB. And we know that because of the right angle marking there. All right, everything coming together with our prior knowledge. And now I'm going to write on the screen. Here we go. We're going to solve some problems together. By together, I mean I'm going to do this and you're going to follow along with me. So here we go. If JK is tangent to circle L, find X. So if they are tangent, then I know that that's a right angle, and I can use the Pythagorean theorem here. So just a reminder, a squared plus b squared, yeah, nice handwriting, equals c squared. That's what I'm gonna use. So I should get my calculator out. You should have your calculator out. Either you can open up at Desmos tab, use Calculate 84, or Lucas, Vince, whoever else. You can use your own personal handy dandy calculators. All right. So I'll say that 7 squared plus 19 squared equals x squared. A, B, C. All right. So 7 squared plus 19 squared, it gives me 410. And then to solve for x, I take the square root. Around to the nearest 10th. I get 20.2. Nice. Cool. All right, next one. JK is tangent to circle L. So my right angle is here. So I know that this is my hypothesis, but the whole thing is the hypothesis. Hypothesis, hypotenuse. Wow. A couple days out of school, don't know how to act. All right. So since my radius JL is 11, I know that this part is also 11, making this whole thing 18. Okay, so number one was kind of like the easiest one, and then they'll all get a little trickier from there. So you're kind of looking for what are we missing? How can we set it up differently? Okay, so here we go. I have x squared plus 11 squared equals 18 squared. So I can subtract 11 squared on both sides. Get what x squared equals 18 squared minus 11 squared, 203. Take my square root. And then I get x equals 14.2. All right, moving right along. Number three. Number three is similar to number two in that our radius needs to be added in again. So the point of tangency is here, but I don't have my full hypotenuse. If I know that the radius is 10, I can add that in here. So I know my hypotenuse is x plus 10. So 10 squared plus, that's plus 24 squared, equals x plus 10 squared. That's a plus, x plus 10 squared. So 10 squared plus 24 squared is 676. So then if I expand x plus 10 squared, that's just x plus 10 times itself. And then I FOIL it. 676 equals x squared plus, combine like terms, 20x plus 100. So since this is a quadratic, I need to set that equal to 0. So I'll subtract 676 on both sides. And now I have 0 equals x squared plus 200x minus 576. 576. 576, is that a square root? Perfect square? It is. Okay, okay. So, how does that help me? Did I go wrong somewhere? This is awkward. Alright, so I want numbers that multiply to 576 that add to 200. So I'm going to make mistakes. You already know. 676. 10 squared plus 24 squared, 676. 20x plus 100. 100 minus 676. Negative 576. So what if I do okay, well, this is 16. We can go back and figure that out later, or if you can figure it out, let me know where I messed up. I wrote notes to myself over here, but you can't see them because you don't need to see my face. Not right now. It's too much. All right, moving right along to number 4. So looking at this, I know that my right angle will be here at J. This is my hypotenuse, 25, so it'll equal 25 squared. I'm going to add x squared and 11 squared? No, 22 squared. So if I subtract 22 squared on both sides, x squared will equal 25 squared minus 22 squared, which is 141. Take the square root of that. That should be a little less than 12. And it is 11.9. Cool. Seriously, let me know if you figure out number 3, where I went wrong. I did this on purpose to increase engagement. Number 5. Switch it up. All right, a right angle here at J. So 7 squared plus, if JL is x, that means LM must also be x. So if I do x plus x, that's 2x squared equals 25 squared. I did have to put 2x in parentheses because I'm not just squaring the x, I'm squaring 2x. So if I do 25 squared minus 7 squared, 576 again, what a jerk. So now I have 4x squared, no more parentheses. I squared the 2 to get 4. That gives me 576, my favorite number right now. Divide by 4. X squared equals 144. X equals 12. But if the question asked you something like, what's the diameter of the circle? You would say 24, because you have to go back and read the question. But you already knew that. All right angle there. X squared plus 20 squared equals, not 10 squared, x plus 10 squared. My pluses aren't coming through. And so we have x squared plus 400 equals x squared plus 20x. Is that my mistake? Did I write 200 instead of 20? I'm not going back to it. You can do that. Okay, so I'll bring this down here more legibly. X squared plus 400 equals x squared plus 20x plus 100. Since I have x squares on both sides, I'll cross those out. I can subtract 100. Not the color I requested. So now I have 300 equals 20x. Divide both sides by 20. X equals 15. Good for us. Okay, so there's more tangent line properties that'll help us solve some more problems. In fancy math language, if two segments from the same external point, so A and C, are tangent to a circle, if two segments from the same external point B are tangent to a circle, then they are congruent. And I know that they're tangent if they have the right angles. And then if a polygon is circumscribed around a circle, then all sides are tangent. So that means these two segments are congruent to each other. these two, and these two. So it'll help us find perimeter. All right. Find each value or measure. Assume that the segments that appear to be tangent are tangent. All right, we would know that they're tangent if we had a right angle marking there, but alas. 8x minus 19 equals 5x plus 23. So 3x equals 42. And x equals 14. So all we have to do is solve for x. Not bad, not bad at all. Number 8, we have to find PQ. So I set them equal to each other. They're both tangents to the same external point. So I know they're congruent. 6x equals 18. X equals 3. I'm going to find the measure of segment PQ. PQ is 14 times 3, which we know is 42, minus 13. And that will give us 42 minus 13. 42 minus 12 would be 30, and another one, 29? Question mark? I'm remembering. All right. Some water. So sorry. Very necessary. All right, now I'm going to find SV. This doesn't look like we have enough information yet, but what we do know, these are tangents, so they're congruent to each other. So I can set those equal to each other to solve for x. Let's start there. 10x minus 41 equals 4x plus 7. 6x equals 48. X equals 8. Okay, so I want to find SV. That's this segment right there. Well, now I need Pythagorean theorem. So first I have to find ST. 10 times 8 minus 41. So that's 80 minus 41, so that'll be 39. Okay, and SV is the hypotenuse, so SV squared is going to equal 17 squared plus 39 squared. Too bad. So SV squared equals 1810. Take the square root of that. Down to the nearest tenth, 42.5 units. I know that's logical because that's the longest segment. Okay. 2 more. And our time has come to the end for this lesson. Find the perimeter of triangle DEF. All right, since this triangle is circumscribed around circle J, that means that all of these parts are tangent. And if they're tangent, that means that these two parts are congruent to each other. So I do 2 times 11 plus 2 times 16 plus 2 times 9.5. So it's 22 and 32 and 19 gives us a perimeter of 73 units. I wonder how that compares to the circumference of the circle. How interesting. All right, and then finally number 11, find the perimeter of quadrilateral PQRS. So we were given, sorry, you probably heard that. We are given some of the full segments, some of the partial segments, and we kind of have to piecemeal and go from there. So this part, 27.1, so I know that this is also 27.1. If I do 52.5 minus 27.1, that gives me 25.4. So I know this part now is 25.4. Cool. 23 there. So if I subtract 37.5 minus 23, this is 23 also. That's what that looks like. 14.5. And then that's also 14.5. All right, so it looks like I have everything accounted for. So my perimeter is adding all the outside. So I have 52.5 plus 25.4. I'm starting here and going around. Plus 23 plus 37.5 plus 14.5 plus 27.1. Okay, so I should have gotten all the sides. I'll add that together. And I got 180. So the perimeter is 180 units. Cool. Alright, so that is it for our lesson. Your homework is, I know, homework, haha, everything's at home. So funny. I'm gonna put it in quotes because I knew it was funny. It's the same idea. Giving an example of each part using the diagram, so kind of the opposite of what you did in the practice. And then finding the value of x using the tangent properties. Same thing here, just with a little algebra now, little algebra there, okay? And I will put in Google Classroom how I kind of expect this, and then how we'll check our answers. So just be on the lookout for that. Want to see good work from you. I want to know if you have any questions. You can just comment in the assignment itself, or you can join our daily Google chat at 11 a.m. Join our Google Meet Wednesdays at 9 to 9:45, and then an additional Friday Google Meet 9 to 9:45 as well. So hopefully this has been as fun for you as it's been for me. Hope you're all doing well, your families are doing well, everyone's being safe and staying sane. Let me know if you have any questions. Have such a good day. Bye.